Well, good afternoon. I wanted to talk a little bit about the midterm and the questions that I'm seeing. By and large, most people did really well on the midterm. I think the interactive homeworks and the other stuff that we've done in class has worked really well, and I'm really pleased with that. It's important that you get this knowledge and this work for you. So that's been going really well. However, the things that people seem to have struggled with, those are the ones that concern me. And rather than going on to, some more lectures about database stuff, I want to touch on the things that caused people struggles and look at some of those things. Specifically with the setup of VirtualBox, I understand from talking to some of you that this is the first time you've ever touched a virtual machine. They're actually very common in industry, so I want to touch that. And, this is kind of the deal with database is, yeah, there's the part about database that is, here's how you use it. But you got to put it in the right context, that if you're going to have a database, most of the time, it's not going to be on your computer. It's going to be on some remote server farm. It's going to be at Amazon Web Services. It's going to be on a virtual system. Even if you're working in a business where you're accessing a database, chances are that that database is not on your desktop. It's in some server room someplace. A lot of times those server rooms aren't even around where you are. Certainly, you look at a company like Dell Computers, a huge corporation, and their data centers are in Texas, which means if you work for Dell in Seattle and they have an operation there, they have one in Southern California, they have them all over the country and world. But that means that the actual servers are in Texas. And you're never actually going to physically touch those servers unless you happen to be in Austin, Texas. So that's where all of their corporate machines are. Now, these days, they use a lot of machines that they don't own. They use virtual machines too. So they have, users outside, but those machines are even less accessible than the ones that they own and put in their own server farm. And they manufacture computers. So, they have an incentive to use their own computers in their own server farm because it's cheaper, but they still use other people's computers. So let's take a look at VirtualBox. VirtualBox allows you to run a host system, that's your desktop laptop, with a client, that's the virtual system. So in the notes, if you look at this, I've put these screen captures in the notes, but I'm actually going to walk through it. You'll notice down here in the notes it says network. We're going to talk about setting up the network so you can access the client, that's the virtual machine, the Linux system, from the host, your desktop, your Mac, your Windows PC system. We were a Windows 10 system. So the first thing we want to do is in the configuration, go in, and I've already configured this one, but if you click on the word network, it gives you this pop-up box. And by default, it comes in at NAT. You want to set it to bridged adapter. And I'm going to hit cancel because I've already set mine. But it is in the notes. That's what you're looking for, is network and bridged adapter. Now, when you have a bridged adapter, there are other network choices there. Okay? And there's reasons why you might want to use those. But as soon as you do that, if you have a system, now this black window here is my Mac system that I'm on. And over here is the purple window. Over here is the purple window with my Linux system. Let's bring up a terminal inside that Linux system. And in search, I'll just type terminal. So that we have a terminal. And you could use a bigger window than this, so could I, but we'll just live with this. If I do IP adder in that window, it gives me a bunch of information. The one that I am looking for as I look down through this information is probably this one right here. Okay? I'm concerned because it says /24 behind it, but I think that's actually the one I am looking for. But one of these ones, in my case, that starts with 192, and you need to know something about networks to pick this out. A Class C network, okay, which is probably what you have when you're on your computer, is a local network that starts with 192. There's a Class B network that is 175, or 172, depending on some configuration, usually 172. And there's a Class A network that is 10 dot. If you're connected to the University of Wyoming's network, and you have your computer, especially if you have, for some reason, hardwired it to their network, it will be a 10 dot network. So the number we're looking starts with 192. It'll be 192, 168 something. The network that I am on at the moment is a 192.168.0. That 0 may be a 1 or other numbers. And this one is saying 75, which I think is in the range of numbers that I would expect. The IP address has got 4 parts, 4 8-bit numbers, so there's 0 to 255, and 75 seems like the right one. Now, I should be able to go over here to my other system and ping it and see that it responds to something. And to get out of ping, you do a Control-C. Some pings stop after 4. Most of them run continuously. Ping just requests a packet response from that system. Now, once I know the address, and that's after I've set it up over here to be network and bridge, that means that I can actually access it from my host system. And the way that I choose to access it is to use SSH. And my account is pschlump on there. This is the account on the Linux system. And I put in an @ 192.168.075. And it says connection refused. The reason for that is I do not yet have OpenSSH installed. So if I do sudo apt install, and I install an OpenSSH server, say yes at the prompt that you can actually use up some space to do this. And now let's try it again over here. Then we should be able to connect to it from our system. It's going to ask for this fingerprint. Type in yes. And then it's going to ask for the password. Now that's not the password to your host. That's the password to your client Linux system that you've set up. And I am logged in. Now, the nice thing about being logged in here is that if I do ls-l, I'm looking at things here. Let's just create a file, just do ls, okay, and I do ls-l again. Have to put a space in there. But I've created this file, isitme. If I go over here on the system now, and I do ls-l, you'll see that we're actually on the same system. There's isitme. So this gives me the ability to log in from my Mac or from my Windows 10. It has SSH in it, and be able to log in. But SSH also includes the ability to copy files. So after we have set it up so that we have the address and we can copy files, I can log into that system. And the example in here uses 47, even though my thing uses 75. That's because this was, when I wrote this, this was at 47. That address can change. You may have to bring it up and look at it multiple times when you use it. But we can go and we can actually set this up to copy files, and that's this SCP, Secure Copy. Almost every system administrator I know uses Secure Copy. So I can log out here. Now remember, this is currently logged in my Linux system by doing a Control-D, which is an end of file to the bash shell running. And I can take some file I've got here, like bob.sql, and copy it to that system. So I say scp bob.sql to pschlump at 192.168.075, and I have to put in the path, which means I need to know that path, and I know that when Linux systems create a home directory, it'll be in home, the name of the account. So if I copy that to there, it'll ask me for the password again. And it says that it copied it. That didn't take long. It is sitting on the same computer. And now if I do ls-l again, you'll see that I have the file there. Now let's change this file. And let's say that we're going to have two variables in it. Just 2 columns. So you can see that I added this, and I don't have that copy over here on this system. So if I want to copy it back, I can do it in the opposite order. I can say that I want to copy from that system to the current system and copy the file back. Again, it asks me for the password. And it copies the file back. Except I forgot to put in the file name. That was important. And it copies the file back. Now, if I actually look at the file here, you'll see that I have on my host, the Macintosh or Windows system, I have the file that I have on the Linux system. So that's basically how you copy files back and forth with SSH. The next thing I'm going to show you is how to do this without having to type in the password every time. SSH uses a very strong system for handling passwords based on a thing called Secure Remote Password, which is a cryptographic standard. And it's a very, very good way, but it's only as strong as the password that you supply. And most remote systems these days use a stronger system than that because human beings tend to produce weak passwords that is based on public-private keys. And to do that, you have to have a public-private key pair on your host system, your Mac or Windows system, and then you copy the public key to the destination system, in this case the Linux system, and when you use SSH, it uses these keys to authenticate, and you can just copy them back and forth. You don't have to enter any passwords, and especially you notice how many times I had to type a password there, you get rid of that. It is very handy to set this up. So, we're going to walk through how you set that up and what it takes to set that up. Now, as I do this, I have many different public-private keys, so I'm going to be setting up an additional key with my ones that I already have, because I use this stuff all the time. My little home lab has multiple computers. I use SSH for copying. SSH is used inside other applications, like Visual Studio can use SSH, as well as VS Code can both use SSH to access remote files. There are backup tools, there are administrative tools. Ansible is a good example. It is the, as far as I'm concerned, best system for deploying multiple computers across a network and getting reliable results. It runs on top of SSH. So lots of tools use this and use this capability to access and use these keys. Now, let's talk just briefly about how this works so that you can understand it. When you do SSH or SCP to a destination system, either copying to it or from it, it contacts that destination system, and the system sends back a random message to sign, or it sends back an indication that you have to use a password. So, provided that the system has keys that it can authenticate, it'll send back this random message. The message doesn't mean anything. It's a big, long, random number. But it's used in the cryptographic process. Your system then takes its digital signature, its public-private key, and it uses the private piece, which you've got to keep as a secret, to do a digital signature on the random message. Then it sends back this signature to say, okay, I can prove who I am to you using this signature. The remote system, in this case the Linux system, gets this back and says, oh, to verify a digital signature, what I use is the public key of the person making the request. So it goes down through its public keys that it has, and it says, does any one of these public keys authenticate this person to log in? And as it looks at this, it says, oh, this key that I have, that's a public key, that I'm authorized to use by this person, says, okay, this signature validated, which means the person had to have had the private key. And when it gets this validation, it says, oh, I'll log you in. And you notice nowhere in this was there a password that had to happen. Okay, so it's relatively quick, it's super strong, it's cryptographically strong. This is the kind of authentication that AWS and Azure and Google Compute Cloud these days basically require for login. They don't even give you the choice of having a password. When you create a virtual system, they set up a public-private key. You download both pieces. They do not keep the private key. They only keep the public key. So if you want to log into that system, first of all, you need to keep your private key private. That should be inherent in the name private key. Second thing is, if you lose your private key, you will not log in ever again. Okay, it is over. So you got to make backups of your private keys. If they're gone for all eternity. And I think that's an important lesson in how you handle keys in and of itself. So, we're going to talk about passwordless login. The first thing that you need to know is you have to generate a key. And SSH keygen, I am using this particular kind of key. There are references at the bottom. Some of them are using RSA. Some of them are using other public key cryptography systems. Now, when we create a key, this key ends up in a directory called .sh in your home directory. And this is true also on Windows. And I know lots of you are not used to things that are like start with a dot, but that's where it is. So in your home directory, you end up with this directory .sh. If you don't have it, I've given you instructions for creating it. But usually by this point, since you've already logged into another system, you have a .sh directory. Now, when we create this key, okay, it's going to ask you a whole bunch of stuff. Let's actually go create a key. Let's see what keys I have. I already have an ED25519, but I don't have an RSA. So let's do SSH keygen. We'll create an RSA key, which is not in my example in the notes, but I already have the other kind. And you'll notice it asks you where you're going to put it. Just hit a return. It asks you if you have a passphrase for it. I generally don't use passphrases. If you use a passphrase, then you're going to have to use a key manager and enter the passphrase every time you use the key, which the purpose of a remote passwordless login is to not enter a password, so that kind of defeats the purpose. So just hit enter when it asks you those things, and it prints some stuff out. And now, okay, I have, yes, a new key. In this case, I created the ID RSA. These are files that you can actually edit if you want to. And this is the one that's public. The reason there was a blur over my private key is that's actually a used private key. I don't want you to know what it is. So I blurred out that section of the screen when I brought it up. But when you create your keys, there is the stuff. Now, there are some other files in this directory. Known hosts is the set where you've accepted that this host is a particular thing. You remember when I first logged in, it asked if the fingerprint was correct. You can check fingerprints. If you're on a high security system, you're going to want to. But I just said yes, and it put it in known hosts. So it knows that the IP address of this system is in that known host. Let's edit that file. Nothing is spelled correctly in large binary numbers, but this file has got text in it, and it has keys at different addresses. Now remember I said that the IP address of your Linux system could change? If it does, it's going to get a bad fingerprint, and you come into known hosts and you delete the old one. You'll notice that the last one that I added down here was .75. This doesn't happen often, but it tells it what this fingerprint is and validates it. This prevents people from going in and creating a new system at a different address and trying to lie with the network about where the system is and what the system is. But it also means that if your router changes the address of that Linux system, which it can do, mine is set to do it every 3 weeks, so it does happen, I will have to go into the known host, delete that, and accept a new fingerprint. And it'll be at a different IP address instead of .75. So, what we've done is we've created a key, and now we can copy this key to our destination. And that's this SSH copy ID. You put in the account and the IP address of the destination you want to copy it to. So I want it to go to pschlump at 192.168.0.75. And it copied a RSA key up there. If I go and look on this system, it's probably going to prompt me for a password again. I should be able to find that key. Now remember, we don't have passwordless login set up yet, so it's prompting me for the password of my Linux system. And it added one key to this. And it suggests that you try logging in at this point to see if it worked. If we look over here on the Linux system in the .ssh directory, you'll see that we have authorized keys now. Authorized keys is that key that just got copied in. And it takes care of all the setup, the permissions, that kind of stuff. So I should be able to now do passwordless login. And if I try to log in, no password prompt, I'm in, it works. Okay? So this is helpful because now I can just use SCP to copy things back and forth between the different systems. Now, I'm also going to cover a bunch of stuff having to do with permissions and files and directories and accounts on Linux. Again, the reason for this in this database class is this seems to be the part that people are having trouble with. It's not the database stuff. I think all of you did awesome on the midterm. And I'm seeing good work in the homework. So, that makes me excited to see that you're getting that stuff down. But a lot of you are having trouble with here's the system, account, Linux, all this other kind of stuff. Now, in the rest of the semester, we're going to touch on things like pgadmin, which is a really useful tool. I use it frequently, but I also recognize its limitations. And it is a web-based tool, which works better. There are administrative tools that are actual desktop graphical user interface tools. They're expensive, so we're not using them. But generally speaking, when I'm administering and working with a remote database, I'm using the command line. Because, it takes time for light to go between here and Tokyo, between here and Texas. And anything that's a GUI, not a web application, but an actual desktop GUI, the design assumes you're working on the machine or very, very close to the machine, so that lag is not very much. If I'm trying to click on something on a remote system, it's like I move the mouse because I want to click on this link down here and I have to stop. Then I have to wait for the cursor to move. It finally moved. Okay, now I move the mouse again and I want the third one down, but I didn't get to the third one. I'm getting closer. I move it down a little bit more. I wait. I move it down again. Finally, I'm on it. I hope I can click on it because you've got to send the data all the way from you to wherever and back again. And that makes GUI applications that actually allow you to administer stuff very, very difficult to use at a remote distance. And with most of these computer systems being remote today, I have by and large switched back to command line access when I'm talking to a remote system. There are command line tools. I use VI as an editor. It was designed to be able to take and handle this kind of lag without difficulty. And I can administer and work very effectively without this other hassle in my life. All right, let's take a look at a few things so that you have a better understanding of how the Linux file system, the Unix file system works. And we'll go from there.